Okay, welcome back to our daily SAT practice videos. We'll look at 5 more practice SAT problems. Again, I recommend pausing the video at each problem and attempting it before you watch the solutions. And these problems will be the student provided response, bubble and response problems that happen at the end of both forms of the SAT test. So don't be surprised by these. They're not harder than the multiple choice problems. Some of them actually I believe are easier. Um, but some people go in not understanding that basically you just solve the problem and then bubble it in. And there's a lot of flexibility in how you bubble it in. Okay, so let's get started. If t is greater than 0 and t squared minus 4 equals 0, what is the value of t? So as I said before, this t greater than 0, it's important to the problem, but for the most part in solving this problem, I'm going to almost just ignore this. I'm going to do the algebra, and then at the very end, we'll see why this is important. So in solving this, I have a couple of options. One option is to just solve it like any other equation, because I have a t squared but no t. So I could add 4 to both sides, and I would get t squared equals positive 4. I could mentally do this, or I could do the square root to try to get the inverse of squared. When I do that, I would generally have a plus or minus. So t would equal the square root of 4 is 2. And here's why they included this to begin with. There is no way to put in negative values in this style problem. So I can't have an answer of negative 2. So if I know that t is bigger than 0, the only possible value was t equals positive 2. And so I'd write 2, I'm going to write justify it, and I would bubble in the 2 completely and fully. Now another possibility, if you don't like that method, and this is sometimes a good method to go for, is I could factor this. T squared minus 4, that's a difference of squared. T squares. T squared is t squared, 4 is 2 squared. So I know that that would be t plus 2, t minus 2, and since I have the product of two things equaling 0, I could use zero product property and set t plus 2 equal to 0, or t minus 2 equals 0. Subtract 2 from both sides, either t equals negative 2, or add 2 to both sides, t equals positive 2, and again, going back to saying that t has to be positive, this is my only solution. Alright, give this a shot. Okay, so a summer camp counselor wants to find a length x in feet across a lake as represented in the sketch above. The length represented by AB, or the lengths represented by AB, EB, BD, and CD on the sketch were determined to be 1800 feet, 1400 feet, 700 feet, and 800 feet, respectively. Segments AC and DE intersect at B, angle AEB and CDB have the same measure. What is the value of X? Okay, so a lot of stuff. This is some good solid geometry. Let's label some things. So when they say respectively, that term, not cross it off. When I say respectively, that just means that the first one here goes with the first number. So AB will be 1800 feet. I'm just put the number because I'm lazy. EB will be 1400 feet. BD will be 700 feet. CD will be 800 feet. Let's see, CD 800. Okay. Now, they intersect at B. I know, because these are vertical angles, that angle ABE and CBD will be congruent. I'm also given that these are congruent. So the rationale behind this is these two triangles have to be similar by angle similarity. Since all three angles add up to 180, I know these are the same, I know those are the same, then the remaining angle must also be the same. And why that's important is, since they are similar, that implies that the sides are proportional. And so I can set up a proportion. And I just need to assign the correct sides. So I know two sides of this. So let's consider these. I have side BD, which is between the 2 arc and 1 arc. That would correspond to the 1400 between the 2 arc and 1 arc. So I would have 700 over 1400 equals, I have CD, which is 800 between the arc and the arc with the hash in there. That corresponds to the x, so I would have 800 over x. And I could solve this by cross multiplying, get 700x equals whatever 800 times 14. I guess, let's see, 8 times 4, 32, with, all right, a mess. I don't really want to deal with that. So here's what I notice. The pattern I'm seeing is this is 2 times that. So then this has to be 2 times that. And 2 times 800 is 1600. So I could do it this long way. It'll get me the correct answer. But this is a whole lot easier. So let me just do it that way. So 1600 feet. 1, 6, 0, 0. Give this one a shot. Okay, so in here we have a system of equations. It's the third system we've had on this test so far. We've only had 18 problems, so system's pretty important for your SAT score. According to the system of equations above, what is the value of x? Now, if I weren't thinking too carefully, I would just dive right in and say, well, I can cancel out the x's by subtracting. I get negative y. I would get a positive 16. I'd get y equals, let's see, I get y equals negative 16. And I can work it out that way. But I'm not going to do it that way. I'm going to be a little bit smart about this. I want to find the value of x. That means if I can get rid of the y's, then I'm going to be done. I'm not going to have to find both variables. I just need x. And so I will actually multiply this first equation by -2 so I can get rid of the y's straight away. So I would have negative 2x minus 2y equals positive 18. And this one I will rewrite as is. X plus 2y equals negative 25. Those cancel. I get a negative x, and when I go through, that would give me a negative 7, which means that x will equal positive 7. If I'm pressed for time, I'll write my 7 down, I'll fill in the circle, and I'd go on. If I have the time, I would go ahead and solve for y and check my answer. So I could put the 7 in here and say 7 plus y equals negative 9. Subtracting 7 from both sides would give me y equals negative 16. And then if I check the other one, it better work out. 7 plus 2 times negative 16 equals, hopefully, negative 25. 2 times negative 16 is negative 32, and lo and behold, 7 minus 32 is in fact negative 25, so I can now be much more confident that I'm right, even though if time is an issue, I would skip over this part. Okay, this one, give it a shot. So this one is probably one of the easier problems on here if you know what you're doing. So in a right triangle, one angle measures x degrees where sine of x degrees is 4/5. What's the cosine of 90 degrees minus x degrees? So this is basically called the cofunction identities. And it basically goes like this. We have a right triangle. Let me draw a right triangle. What a lovely right triangle. Actually, let me make a bigger right triangle because I'm going to be writing things inside of it. Okay. We have one of our angles is x degrees right there. And I know that the sine of x degrees is 4/5. And from our right triangle trigonometry, we know that we know that sine is the opposite over hypotenuse. So one possible setup for this right triangle is this leg, the opposite to the x degrees being 4, this hypotenuse being 5. This is just one of the possibilities. This could be 20, this could be 25, just one pair so that when I divide them I get 4/5. Here's where the magic happens. We don't have an x, we have 90 minus x degrees. But notice, if all three, let's give this angle a name. We'll call it y degrees to begin with. All three of these have to add up to 180. So I know that 90 degrees for this angle, plus x degrees for that angle, plus y degrees for that angle has to be 180 degrees. And if I were to subtract the 90 degrees and subtract the x degrees from both sides, then this angle right here will be 90 degrees minus x degrees. So this right here is just 90 degrees minus x degrees. Every time you see that, you're just sort of switching which angle. So the original trig ratio was based on this angle. The new trig ratio right here is based on this angle. Cosine is adjacent over hypotenuse. Adjacent to this angle is 4, hypotenuse is 5, and hey, look, it's still 4/5. Now I could write this 4 over 5. I have the fraction bar, that's what I would do. I could also, if I love decimals, change it to 0.8. That does not matter. So either way works. And addressing this again, 4 and 5 are just one possibility. If I wanted to sort of account for every possibility, I could put in some variable here, let's say 4z and 5z. And so this would account for every possibility. That would give me a sine of 4 over 5. Okay, last question from the first part of this. Give it a shot. Okay, so this is another, it's pretty much a system. It's kind of silly. It's just an equation. But we have a is equal to 5 root 2 and 2a is equal to root 2x. We want to find the value of x. So what I'll do is this. I will take this value and plug it in for a. So I will have 2 times 5 root 2 equals the square root of 2x. I will multiply the 2 times 5 root 2, and it doesn't distribute. There's no plus between here. This is a number outside of a root. This is a number outside of a root. So 2 times 5 root 2 is 10 root 2. Now, to get rid of the square root, I will square both sides. And that means I will square the 10 and square the root 2. So what's happening is I have 10 root 2 times 10 root 2, which really means I'm going to do 10 squared and I'm going to do root 2 squared. 10 squared is 100. Root 2 squared is 2 because the square root and squared cancel, or 2 squared is 4, square root of 4 is 2. So all this mess down here becomes 200, and that will equal 2x. And to wrap it up, we will divide both sides by 2 to get x by itself, and x will end up equaling 100. Bubble it in, and we're done with the first part of the SAT math.